Hello everyone. So today we are going to continue with graph theory. We are going to learn about some special types of graphs or special families of graphs. The first one is complete graphs. In a complete graph, every pair of vertices are adjacent. Kn denotes a complete graph on n vertices. So for example, let's draw some complete graphs for n equal to 1, 2, 3 and 4. So the first one is K1, a complete graph with one vertex. This will look like just a single vertex. So this is K1. This graph has only one vertex and 0 edges. Next is K2, a complete graph with two vertices. So two vertex and there is only one edge joining them. So two vertices, one edge. K3, so there are three vertices, and if all of them are adjacent to each other, then three vertices, three edges. Similarly, K4, there are four vertices, all of them are adjacent to each other, so there are 6 edges. So K1, K2, K3 and K4. Let's see. So for Kn, number of vertices is n, number of edges is n choose 2, since all edges are present, which is equal to n times n minus 1 over 2. And degree of each vertex is exactly n minus 1. Every vertex is adjacent to all the other vertices. So the degree of every vertex is n minus 1. Next is cycles. Cycles are denoted by Cn. A cycle has at least 3 vertices and they are labeled as V1, V2 up to Vn, and every vertex Vi is adjacent to the next one, Vi plus 1, and the previous one also, and Vn is adjacent to V1. So the cycle with 3 vertices, the smallest cycle, looks like this. C3, 3 vertices and 3 edges. Similarly, C4 looks like this, another cycle with 4 vertices. C5 looks like this. Okay, and if you remember C3, the triangle looking C3 is also same as K3. So different or same graph can belong to different families. So this graph is denoted by Cn. Number of vertices is n. Number of edges is also n, and the degree of each vertex is 2. Every vertex is adjacent to the next one and the previous one. Next is bipartite graphs. A simple graph G is bipartite if the vertex set V can be partitioned into V1 and V2 so that every edge in G is between a vertex in V1 and a vertex in V2. So let's try to draw it. Let's say the graph looks like this. 3 vertices in V1 and 4 vertices in V2, and all the edges that you can draw are between V1 and V2. So for example, this is set V1, this is V2. So you cannot draw any edge between the same part. So no edge between these two vertices or these two vertices, no edge between these two or these two. So that's how bipartite graphs are drawn. Another way of viewing bipartite graphs is to color them. For example, this graph can be a bipartite graph. Now this is G, let's say G1. We are drawing a different graph, G2, and this is bipartite. So let's try to color these vertices. So red, blue, red, blue, red, blue. So you can color every vertex with 2 colors, red or blue, and if there is no edge where the both endpoints of that edge are of same color. So you can add few more edges here, red, blue, red, blue. So this is not a vertex. So this is bipartite. Okay. No edge between the same color is allowed. So you cannot draw an edge like this. If you draw an edge like this, then it won't be a bipartite graph anymore. Next we discuss a special type of bipartite graph, which is complete bipartite graph, and we'll encounter this type of graph often in this course. So K N1, N2 is a bipartite graph with the vertex set partition into V1 and V2, so that the size of V1 is N1, size of V2 is N2, and every vertex in V1 is adjacent to every vertex in V2. So the difference between a bipartite graph and a complete bipartite graph is all the possible edges that you can draw, you draw them, then you get a complete bipartite graph. Let's try to draw K3, 4. So previously we did a bipartite graph with 3 vertices on one side, 4 vertices on other. This time we are going to do a complete bipartite graph. So this vertex is adjacent to all 4 of these. This is also adjacent to all 4 of these. This is adjacent to all 4 of this. So this is K3, 4. So V1, the left side, has 3 vertices, V2, the right side, has 4 vertices, 3, 4. Now given a complete bipartite graph, Kn1, N2, number of vertices is N1 plus N2. There are N1 vertices on one side, N2 vertices on other side. Number of edges, you can calculate that. Each of these vertices are adjacent to all of these vertices. So N1 times N2. And degree of a vertex. Now that gets a bit complicated compared to the previous ones. So when you say degree of a vertex, it is not same for all vertices. There are two cases. If it belongs to V1, the degree is different if it belongs to V2. So if this is V1, for each vertex here it is adjacent to all these vertices here. So the degree of a vertex belonging to V1 is the size of V2, which is N2, and the degree of a vertex belonging to the right group here is the size of V1, which is N1. So we should write down here also that size of V1 is N1, size of V2 is N2. Next, we learn about few other terminologies and relationships in graphs. So the third definition is H is a graph, vertex set is V prime, edge set is E prime. H is a subgraph of G, which is V comma E, if only V prime is a subset of V and E prime is a subset of E. That means a graph H is subgraph of G if its vertex set is a subgraph of the original and if its edge set is a subgraph of the original. So let's see how to draw subgraphs. So our original graph G, let's say it has 5 vertices. A, B, C, D and F, and this many edges. So this is G. Which is V comma E. Now let's draw its subgraph H. So we take a subset of the vertices. So for our example, let's choose these 4: A, B, C and D. And we take a subgraph of the sets. Let's choose this edge, and this edge. Okay, so let's see. In this subgraph H, we have chosen this vertex, this vertex, this vertex, and this vertex. So definitely V prime is a subset of V. We have chosen this edge, and this edge. So E prime is also a subset of E. So H is a subgraph of G. Let's try one example where it is not a subgraph. Let's try to draw this. So we choose A, B and E, these 3 vertices. Now, F. These 3 vertices. Now we have A to F, A to B. But the moment we put an edge between B and F, it is not a subgraph anymore. It is not a subgraph of G because the edge BF does not exist in the original graph. So it cannot exist in the subgraph. So due to this edge, this graph is not a subgraph. Next, we learn another example or new definition is complement of a graph. The complement of a graph G is denoted by G bar, where you have the same vertex set V, but the edge set is the complement of the edge set of the original graph G. That means in the complement graph, though the edges exist only if it did not exist in the original graph. So let's try this example. You have this same graph G, where you have these 5 vertices A, B, C, D, F, and these edges. So what is G complement? How to draw it? It will have the same vertex set and a different edge set, which is the complement of the original. So same vertex set means we will have A, B, C, D, and F. Now look at the original graph. Between each pair of vertices, if the edge is present here, it will be absent here. If it is absent here, then it will be present here. So let's see. AB is here, so it won't be here. AC, AD, and AF are also here, so it won't be there. From B to AC is here, so it won't be there. But BD, this edge is not present here, so there would be an edge here in the complement graph. So if you look at all these pairs, you will see that the complement graph looks like this. These 3 edges were not present in the original, and all these other pairs were adjacent in the original. So in the complement graph, these are the only 3 edges. Again, this is not a vertex, this is just a crossing over. Now, here is an important observation for complement graphs. If the size of the vertex set is n, then in the complement graph it's the same vertex set, so the size also is n. But the size of the edge set of the original graph and the complement graph add up to n choose 2, or n times n minus 1 over 2. For example, in this case, phi is 5, so this also has 5 vertices. E is, how many edges are there here? There's 7 edges. E prime, how many edges are there? 3 edges. So E, size of E plus size of E prime is 7 plus 3 equal to 10, which is same as n choose 2 or 5 choose 2. It is same as 5 times 4 over 2. So given a graph, and if you know how many vertices are there and how many edges are there, without drawing you can calculate in the complement graph how many vertices and how many edges will be there.